Okay, so for this video, we'll be discussing paper 3 for October-November 2021. All right, paper 3 lah. Right, okay, so let's have a look for question number 1. For question number 1, they want us to find the quotient and remainder when this polynomial is divided by x squared minus x plus 2. Okay, so let's start. But if we want to find out the quotient and remainder, right, basically there are two different methods that you can try to apply here. The first one, I'm going to use the long division, where long division means that you write the polynomial inside where you are having 2x power 4. There's no x power 3, right? So usually I will keep a space for x power 3, but I will just put 0x power 3, then 0x power 2, 0x plus 1. Okay, so that I won't feel so confusing later like when I carry out the long division. Then I'm having x squared minus x plus 2, so it will be our divisor. So x squared minus x plus 2. So first of all, to decide, I want to decide something to multiply with x squared to get the 2x power 4, right? So what's the something here that I should consider? So by right, it should be 2x squared. 2x squared multiplied with x squared so that I can have 2x power 4. Therefore, the very first term on top is 2x squared. So 2x squared multiply with 2x, multiply with x squared, multiply with x squared, okay, together 2x power 4. So I write 2x power 4 here. So at the same time, these 2x squared have to multiply with negative x as well, the negative x. So 2x squared multiply with negative x, I'm having negative 2x power 3. So I write 2x power 3. Same thing happened, 2x squared, you need to multiply with the 2. And you should have 4x squared. So you put a 4x squared here. Then you draw a line, okay? Then just continue. Take the term on top minus the term at the bottom. So first term always 0. Okay, so 0 minus negative 2x power 3, you get 2x power 3. Then for this term, 0 minus 4x squared, so you're having negative 4x squared. Then copy down the remaining term from the top. Alright, then now you want to focus on something, multiply with x squared to get 2x power 3. So what's the something here? The something here should be 2x, right? So that 2x multiply with x squared, then I get 2x power 3. So I will write here 2x power 3. Same thing happened, 2x multiply with negative x. So I'm having negative 2x squared. Then 2x multiply with 2. So you're having 4x. Then again, you take the term on top minus the term at the bottom. So negative 4 minus negative 2, you are having negative 2. 0 minus 4, you get negative 4. And then plus 1. Okay, so the last one. Again, you have to think about some term so that when this answer multiply with x squared to get negative 2x squared. So the answer should be negative 2. So negative 2 multiply with x squared, you get negative 2x squared. Negative 2 multiply with negative x, you get positive 2x. And after that, negative 2 multiply with 2, you have negative 4. Okay, so here let's have a look. What do we still have? So you take the term on top minus the term at the bottom again. Right, so negative 4x minus 2x, you should have negative 6x. Then 1 minus negative 4, you get a positive 5. Okay, so the remaining term here, right, the highest power is x power 1, but in our divisor, there's x power 2. Therefore, you cannot continue to carry out the long division anymore, which means that this particular term here will be our remainder, and our quotient will be the answer on top. So usually for me, I will just write out again. So for quotient, the answer is 2x squared plus 2x minus 2. And how about for the remainder? So remainder will be the term at the bottom here. It will be negative 6x plus 5. Okay, so this is how we basically get the remainder and quotient by using the method long division. Okay, alright, so there's another method that you can try to consider where you try to use comparison. Right, so to use comparison method to carry out the division, right? Okay, to find the quotient and remainder, right? I will just show you roughly how to start, and then you can continue by solving it by yourself, right? Okay, so if let's say I'm having, I want to use the comparison method, and basically you need to know that there's a general formula between polynomial and the divisor, which is polynomial is equals to quotient multiplied with divisor then plus remainder. This is a general formula that you should know if you want to carry out a comparison method. So what is a polynomial in this case? Your polynomial is actually 2x power 4 plus 1. And quotient I don't know, but divisor I know that it is x squared minus minus x plus 2, right? So minus x plus 2. And then the remainder is negative 6x plus 5. Okay, all right. I don't know the remainder, so I shouldn't put remainder yet. I'm so sorry for that. Okay, so now to put in the quotient, right, I need to know what is the first term of my quotient. So for the first term of the quotient, you can always decide it now straight away from the divisor. So you ask yourself, x squared multiply with something to get the 2x power 4. So the something here, I think very straightforward, it should be 2x power 4, right? As the 2x power squared, 2x power 2. So I know that 2x power 2 multiply with x squared, then I get the 2x power 4 equals to the polynomial. Then after that, for the remaining term in the quotient, I don't know what is the constant term. So I don't know what is the value, what is the coefficient. So after 2x squared, I will write ax, then I will write b. I will continue the quotient term, right? Quotient answer until the constant term. Alright, and later I want to find the value for a and b. Okay, then after that, how about the remainder? So for remainder, it depends on the divisor. The divisor, if the divisor is having degree equals to 2, then the remainder will be 1 degree lower than the divisor. So the degree should be equals to 1. If the degree equals to 1 means that you should have x power 1, right? Okay, but what is the coefficient of x power 1? We don't know also. So we will write it as cx, then plus d. So this whole thing is my remainder, and this whole thing is my quotient. So if you want to use comparison method, basically what you need to do is you have to expand everything on the right, group all the x power 4 together, x power 3 together, x squared together, and you compare the coefficient with the left-hand side. So from there, you can slowly get the value for a, b, and c, d. That end up, you'll get the quotient and remainder answer. All right. So to me, personally, I feel that for this particular question, long division is much more convenient, right? Because if you try to expand, then compare the coefficient by using this method, basically it will be longer, and you need to be very, very careful so that you won't do any careless mistake. All right. Okay, so these are the two possible methods that you can use to find the quotient and remainder in the division of polynomial. All right. Okay, so we come to question number 2. They want us to sketch the graph, y equals to modulus 2x minus 3. So before I sketch the diagram, usually I will want to sketch the original graph without the modulus sign first. So if I have a look for y equals to 2x minus 3, right? So to sketch this linear function or linear graph, so usually I will find out the x and y intercept. So I will let x equals to 0, then I get the y equals to negative 3. And then when I let y equals to 0, and I will get x equals to 1.5, right? 3 over 2, which is 1.5. Okay, then after that, what I do is that I will try to decide the ratio for the x and y axis. Okay, I'm having x and y here. So maybe I'm using 1.5 unit. This is 1.5 maybe for 1 cm. So the other second cm will be 3. Same thing happened for the y-axis here. I'm using 3 over 2 and then 3. Then 3, negative 3 over 2, then negative 3, and so on. So I'm having negative 3 over 2 and also negative 3 here. Okay, then when I want to sketch the diagram, right, original graph, I'm having y-intercept negative 3. So y-intercept negative 3 will be here. Then x-intercept is 3 over 2. So 3 over 2 will be somewhere here, which means that if I try to connect the line together, it will be something like this. So it is a linear line, right? Linear line. So it should be looking something like this. Okay, so of course my line is not so nice. So make sure you draw a straight line. Okay, then when I put a modulus to the graph, okay, when I put a modulus to the function, basically it means that I need to change all the negative graph become positive. So you can see that this part of the graph is negative. So I want to reflect it up, become positive. So when I reflect it up, okay, so this part of the graph will be reflected up on top. So the original y-intercept is -3 will reflected up become +3. So if you try to reflect the graph up, it should look something like this. Okay, so this is what I can show you for the modulus 2x minus 3. It should be a V-shaped graph. Okay, and then the x-intercept is 3/2, and also the y-intercept for the modulus function one is 3. Okay, so basically this is how I sketch the graph in detail, right? If you want to follow the step, basically this is what I draw usually. Okay, then after that, they want us to find out, solve the inequality for modulus 2x minus 3 smaller than 3x plus 2. Okay, some students, they might want to draw another graph here to see how many intersection points that they have. Okay, so for me, I will just carry out the steps and then try to check the answer. And usually for inequality that involve the modulus function, right, what I'm going to do is that I will try to put it as equal sign first. I want to find the intersection point between these two graphs first. Alright, so for 2x minus 3 can be separated, become two function. One is 2x minus 3, the other one is negative 2x minus 3. Okay, so I will let 2x minus 3 equals to 3x plus 2. And then another part is negative 2x minus 3 equals to 3x plus 2. Because for modulus function, the non-modulus form can be written as two part of function like this. Okay, and after that, I will want to find out the value of x for the intersection point. Okay, so for this part, I'm having x equals to negative 5. Then for this part, I'm having negative 2x plus 3 equals to 3x plus 2. Then eventually, I'm having x equals to 1/5. So these two values I call it as critical value. That means it is actually maybe the intersection, x intersection coordinate for these two diagrams, these two graphs. Okay, so but for me, I call it as critical point. Okay, so to decide the correct final answer that fulfill this inequality, basically I need to check the answer part by part, where I will use the number line to separate that, okay, or for checking. So I'm having x equals to negative 5. I'm having x equals to 1/5. Okay, so for the part with x smaller than negative 5, so you can use x equals to negative 6. Okay, so for this part, you can use any value that's smaller than negative 5. For me, I'm using negative 6. Substitute negative 6 into this inequality. Okay, into this inequality. So negative 6 times 2 is negative 12. Negative 12 minus 3 is negative 15. Modulus negative 15 is positive 15. So you get a 15 here. Then you copy the smaller sign. Then negative 6 multiplied with 3, you get negative 18. Negative 18 plus 2, you get negative 16. So the right answer on the right hand side is negative 16. So you double check the inequality that you get here for this part. Very obvious, you can see that the inequality is not the correct inequality because 15 shouldn't be smaller than negative 16, right? So that means any answer at this part, it is not the correct answer. So it is a cross. Then the same thing happened for the second part. Take a value between negative 5 until 1/5. So for me to be easy, I will take x equals to 0. So when I take x equals to 0, substitute the value inside the inequality for this one. So 0 minus 3 is negative 3. Modulus negative 3 is a 3. Then smaller than 2 on the right hand side, right? So 0 times 3 is 0 plus 2 is a 2. So 3 is smaller than 2. Again, very obvious, you can see that this value is not the correct value also. This inequality is not a correct inequality. Therefore, the answer from this part is also not giving a correct inequality here. Then for the last part, you can decide any value that is more than 1/5. You can take x equals to 1. When you have x equals to 1, substitute into the inequality here. So 1 minus 3, you get negative 2. Modulus negative 2, you get a positive 2. Copy the sign smaller. So 1 times 3, you get a 3 plus 2, you get a 5. So you see that, oh, this inequality basically is the correct inequality. So that means this is the correct answer. And from the number line that you try to check for the final answer, right, you realize that only this part gives you the correct answer. Therefore, the correct final answer that fulfill this inequality and with the modulus function is so it should be x greater than, okay, so it should be x greater than 1/5. right? So this is how we solve the inequality with modulus function. Okay, so now we are at question number 3. By having this equation, they want us to solve this equation, give our answer correct to 3 decimal places. Alright, so from here you can see that it is a question that involve x as a power of 4, right? So 4 power x. So to get the value of x, for this kind of question, what I usually do is that I will want to rephrase my equation, become something like this. I usually prefer to make my equation become a number power x equals to a number b. So when I rephrase my answer like this, right, then it's quite easy for me, okay, to take ln both sides, then finally I get the answer correctly. Okay, of course there are many different ways, because some students, they prefer to take the ln or log from the beginning. But some students, they take the ln and log too early, where they might have some mistake in there. So usually for me myself, I prefer to rephrase my equation, become a power x equals to b first, where a and b are numbers. Then only I take ln both sides. So I will start from the equation given here. So 4x minus 2, I can separate it, become 4x multiply with 4 negative 2. Okay, that equals to 4 power x minus 4 square is 16. Okay, then here 4 power negative 2, it basically means that it is 1 over 4 square. So 1 over 4 square, what does it mean? It actually means that it is 1 over 16. Okay, alright, so from here you can see that I'm having 4 power x multiply with 1 over 16 equals to 4 power x minus 16. If you feel that 4 power x, and when you write 4 power x into solution is very confusing, you can actually let y equals to 4 power x. If you let y equals to 4 power x and you rephrase your equation, right, so you can see that you're having 1 over 16y equals to y minus 16. Okay, so move the 1 over 16y to the other side. Okay, so you're having 1 minus 1 over 16. So you're having 15 over 16y equals to 16. And then your y equals to 256 over 15. And of course, if you rewrite your y, go back, become 4 power x, right? And this is what you get. 256 divided by 15. So you can see that I already successfully rephrased my equation, become something in this pattern. Something power x. A power x equals to a number on the right hand side. So this is the pattern that I meant just now. Okay, so when I get this equation already, all my x is at one side. So to find out the value of x, what I do is that I can take ln both sides. Either ln or log both sides also doesn't matter. They should give you the same answer, no matter you take ln or log. Okay, so to get the value of x, I'm having ln 256 divided by 15 divided by ln 4. Okay, so by try to press the calculator and get the answer for you, you should able to get a long decimal number. Then we should try to fulfill what they want. So they want us to show our answer in 3 decimal places. Therefore, by right, if you didn't do any careless mistake, the answer should be 2.047. Okay, so this is how we answer question number. Okay, so we come to question number 4. They want us to find the exact value of this integration. Okay, so first of all, when you want to solve the question related to integration, right? First of all, you need to decide what is the suitable method or any specific technique that you want to apply for this integration. Okay, if you have a look for the expression for this question here, basically you can see that they want us to integrate the product of 2 different functions. So you can see that x is one type of function, and then sine half x is another type of function. So they multiply each other together, right? So it is a product of 2 different functions. When we want to integrate the product of 2 different functions, basically we have to apply integration by part. Okay, so for the integration by part, the formula is provided in the formula booklet. You can have a look for the MF19 list. Then scroll down for the integration part. Okay, so this is basically the integration by part formula. Okay, integration by part formula. It is provided in the formula booklet. Then for the booklet here, usually what I do is like I will ask the students, my students, right, to ignore the dx because the dx over dx can be simplified. So this one also the same, dx over dx can be simplified. Okay, so that means your question is u dv, and then to find out the answer, it should be uv minus v du. Okay, so for the question, let's have a look for u and dv. There are two groups here in the original question, u and also dv. So first of all, you need to decide which part of your question is u, which part of your question is dv. Okay, so let's come back to our question here. So to decide which one is u and which one is dv, right? There's a small rules that we need to follow actually. Okay, so the rules is like this. We will follow the Liates rules, L-I-A-T-E. Okay, so where L means logarithmic function, log, ln, and everything. I means inverse trigo, inverse trigo. Inverse trigo in our syllabus, right? We only have tangent inverse. Okay, we don't have any other sine inverse, cos inverse whatsoever, but mainly we are having tangent inverse only lah. Okay, then for A will be algebra. It will be something like the polynomial or number such as x squared lah, then x plus 1 lah, and etc. Then E is trigo. All the trigonometry function, we put it under the T, and also E means exponential function. Okay, so for the higher group, if let's say your function belongs to the higher group, it is U. And then if let's say your function is at the lower group, it should belongs to dv. Okay, so now I want to decide which one is my u and which one is the dv in the question here. Okay, so I'm having x. X is algebra, right? Okay, x is algebra. And then sine half x belongs to trigo. Sine, right? So it belongs to trigo. So from here you can see very clearly that A is at the higher group. Therefore, you need to let u equals to x because A is a higher group, so the x will become the u. Higher group will be the u, right? Okay, then after you decide what is the x already, what else you have in your question? So you still have integrate sine half x dx, right? So you let it become dv. So integrate dv. So you need to decide u and also dv first in your at the beginning of the step, right? By using the LIATE rules, Okay. Then after you decide the u and also dv, then you start differentiation for the u with respect to x. So du dx equals to 1. Okay. So integrate 1 dv, you will get a v. There's a 1 here, basically we just didn't write out. So integrate 1, you get dv. Then integrate sine half x, you have negative cos half x, then divided by the differentiation of half x, it will be equals to half. Okay, then if I rewrite it better, in a better way, then I will have v equals to negative 2 cos half x. Okay, so this is what you need to do at the beginning. Alright, and usually for this part, the integration, we will not put a plus c at the back because this is not the final answer yet for the integration. That means the integration haven't been completed. So you need to continue, and I will keep all the plus c at the last step. Okay, so usually you won't see I put any plus c here. Okay, so after you decide the u and v already, then let us start with the calculation for the answer of integration. So I copy the question first. I'm having half, then pi over 3, and then x sine half x dx. Okay, so the general formula for integration by pi, right? It is u dv equals to uv minus v du. Okay, so this is the question, u dv. That equals to uv. So uv means that the first term of my answer should be uv. So where's the uv here? Okay, so u is x. So I put an x. What is the v? V is this whole thing, right? So I'll put it as negative 2 cos x over 2. And I need to substitute in the limit, which is pi and also pi over 3. So this is uv. Then minus, you put a minus, then v du. So you put the integration sign as well. You put back the limit also. And then you put in the term v du. Again, v is this one, negative 2 cos half x. then what is du? So du is this one. From here you can see du dx equals to 1, therefore du equals to dx. So you can put the dx at the back. Okay, then of course you need to continue with the integration slowly for the next step. For this particular step, there's no more integration sign. So what you need to do is just substitute the limit inside the term. So substitute pi first. I'm having negative 2 pi, then cos pi over 2. Minus, substitute pi over 3. So if I substitute pi over 3, I'm having negative 2, then pi over 3, then cos pi over 6. Okay? Then for this part, second term, I take out the negative 2 become positive, multiply with the negative, it become positive 2, then pi and also pi over 3 cos half x dx. Okay, so try to solve and simplify all the terms slowly. When I'm having cos pi over 2, basically this is equals to 0. This one is a 0, right? Okay, so this one is 0. 0 multiply anything also becomes 0 already. Okay, then for this part, I'm having positive 2 pi over 3. Then multiplying the value for cos pi over 6. Cos 30 degree, it should be square root 3 over 2. Okay, then for this part, copy the 2. Now I want to integrate. You still see the integration sign, right? So you have to integrate cos half x. Integrate cos half x, I will have sine half x. Divided by the differentiation of half x, I have to divide it by half. Then put in the value pi and also pi over 3. Okay, then again, continue further. For this part, 2 and 2 can be simplified. Therefore, you are having square root 3 over 3 pi. Okay, then for this part, I would prefer to take out the half over here first. So something divided by half, multiply with 2, you get a 4. Okay, then now you substitute in the limit inside the sine half x. So substitute pi inside, you're having sine pi over 2. Minus, then substitute pi over 3 inside, you have sine pi over 6. Okay, then again, slowly put in the value for all the sign here. Sine pi over 2 means sine 90 degree, it should be equals to 1. Sine pi over 6 means sine 30 degree, it should be half. So simplify the answer from here, you should have square root 3 over 3 pi, then plus 2. Okay, so basically this is what we get for question number 4. By applying the technique of integration by part in the integration chapter. Okay, we'll keep our answer like this. It is because of in the question it did mention that we need to keep our answer for exact value. That means it cannot be decimal number. You should keep it in either surd form, pi form, and etc. So this is why we keep our answer like this. Okay, so this is how we solve question number 4 for this paper. Alright, so question number 5. They want us to solve this equation, sine theta equals to 3 cos 2 theta plus 2 for the data between 0 until 360. Okay, so to find out this one, so let's start. First of all, to solve this trigo equation, right, I'm having sine theta. Theta is a single angle, but for 2 theta, it is a double angle. And somehow you can see that the trigo involved here is sine and cos, which is different trigo. Alright, so for me, usually I would prefer, if can, I would prefer to change either everything becomes sine or either everything becomes cos. And since we are having a double angle here, then very likely we can actually use our identity to expand cos 2 theta so that it will become theta and also with the sine. So what is the double angle formula that I can use here? So you can, if you can't remember the identity, you can refer to the trigonometry identity provided in the booklet. But for me, I would strongly suggest you to memorize it, because when you have the equation or identity in your mind, right, then it's easier for you, okay, to know what is the next step or which is the correct identity that you can use to solve this question. Instead of you need to still find out from the formula booklet, and then after that you still need to check and decide slowly which is the correct formula to be used, right? So now I'm having cos 2 theta. So I look for the double angle formula. Cos 2 theta, where are they? Cos 2 theta, they are having three different formula. So cos 2a can be equals to cos square minus sine square, can be 2 cos square minus 1, can be 1 minus 2 sine square. For me, I will expand this one. Cos 2a equals to 1 minus 2 sine square a. Okay, so I'm going to use this. I'll write it here. Okay, I will use cos 2 theta equals to 1 minus 2 sine square theta. So you might want to ask, why do I want to choose this one instead of other option like cos square minus sine square? Okay, so basically like what I told you earlier, I prefer to have my equation with all the same angle, which is theta, and also with all the same trigo, which is the sine. Because if you expand cos, right, the left hand side left the sine theta here. Therefore, I choose this one where I have sine and also I have the theta. Okay, so after you decide already, then you start. Sine theta equals to 3 cos 2 theta plus 2. Then sine theta, I want to substitute the cos 2 theta by using this equation. So I'm having 1 minus 2 sine square theta, then plus 2. Okay, expand everything. And then rephrase it. You can try to move all the term to one side. I don't know whether you're able to see it or not, but basically you can see quite clearly that it is a quadratic equation in terms of sine. So sine square theta is like x squared. Then this one is like the x. So you are like having 6x squared plus x minus 5 equals to 0. So when you're having a quadratic equation, to solve it, you need to factorize it, right? So you can see that, I can actually factorize out this equation to solve them. I'm having 6 sine theta here, and I should have a negative 5 here, then plus 1. So that positive 6 minus 5, you get 1, which is sine theta. Okay, so I solve it by using factorization. Then I'm having two equations for the sine theta. Sine theta equals to 5 over 6, and also sine theta equals to negative 1. Okay, then now I want to solve the equation separately. I want to solve for sine theta equals to 5 over 6 first. So for 5 over 6, right, first of all, I want to find a basic angle. So the basic angle is sine inverse 5 over 6. So for sine inverse 5 over 6, by right, you should have 56.4. This is my basic angle. And then to decide for the theta, I need to go through 4 quadrants. Theta between 0 until 360. So I have to go through all the 4 quadrants by having sine is positive in that particular quadrant. So sine is positive in first quadrant. So first quadrant answer should be directly the basic angle, 56.4. And also the second quadrant should be 180 minus basic angle. So 180 minus the basic angle, 56.4 should be 123.6. Okay, then third and fourth quadrant, sine is not positive, therefore I don't consider the answer from that two quadrant. So for this particular equation, my answer for the theta will be these two. So these are the knowledge that we learned previously in AS. Yeah. Okay, then after that, for the second equation here, sine theta equals to negative 1. For this particular question, for this particular equation, you have to solve it by just imagine or get the answer from the original sine graph. So the original sine graph will look something like this. This is 1, this is negative 1, and all the intercept and maximum minimum point, right, the difference is 90 degrees. So this one is 180, 270, then this one is 360. Okay, so they said sine theta equals to negative 1. So you look for negative 1 here. This is the negative 1. Y equals to negative 1. Okay, so what's the value for the x? The x here will be 200. The theta here should be 270 degree. So the third answer for the theta will be 270 degree. And negative 1, the point negative 1 only appear once from 0 until 360. Therefore, I have only one answer for this particular equation. Okay, so combine the three answers together. By right, this is what you should have for the final answer of theta. Okay. Okay, so now we are at question number 6. So for this question, they want us to expand cos x minus 60 first, and after that rephrase this whole expression, become the pattern r cos x minus alpha. Okay, so of course they already give us a hint on how to actually rephrase it into the pattern that we want. So we have to expand this compound angle first, right? So how can we expand this compound angle, x minus 60? So basically you can refer to the compound angle formula provided in our formula booklet. So cos x minus 60, you can refer to this particular formula. So it should be cos A cos B minus sin A sin B. Alright, so we go back to our question here. Okay, so for me, I want to start from the phrase here. Okay, so I will straight away start from the phrase here. So I'm having 2, then cos x minus 60 plus cos x. Okay, so for this particular part, it is cos x minus 60. I want to expand it by using the formula that I showed you just now, which is cos A cos B. So I'll have cos x, then cos 60. Then this is a minus, right? So according to the formula, it should be a plus in the formula here when you expand it. Then I'm having sin A sin B. So sin x sin 60 degree. And then plus cos x. Okay, so next step, we try to substitute all the trigo with the angle with value. Right, so cos x is still cos x. Cos 60, I will get half. So I'm having half cos x for this case. And then sin 60, I'm having square root 3 over 2 sin x, then plus cos x. Okay, then now I want to group all the cos together and all the sin together. Right, then after that, only I can rephrase it into this particular pattern, r cos x minus alpha. Okay, because for this particular final answer that they want us to show, right, it is cos. Therefore, in my expression here, I want to put cos in front and sin at the back. So multiply the 2 in. So this is a 2, right? Multiply inside the bracket. And you try to simplify it. So I'm having cos x plus square root 3 sin x, then cos x. So if I want to group all the cos x together, I'm having 2 cos x plus square root 3 sin x. Okay, and now I want to rephrase this expression, become the pattern like this. Okay, basically we are having a general formula. I don't know whether you still remember or not. Okay, the idea is like this. Basically it is a cos x plus b sin x can be written as r, then cos, then x minus alpha. Okay, so if you want to rephrase it become cos, then it will be preferable that you make the cos x in front. And then for the cos here, inside is a minus, then this one should be a plus. Okay, then we are having a general formula basically. So how to get the r? So r should be equals to square root of a square plus b square. And to get the alpha, it should be tangent inverse, okay, b over a. Right? Okay, so if let's say you want the further explanation on this part, you can refer to the lecture videos that is available in the channel. Okay, so you can go and have a look. Right. Okay, so now how can we continue from here? So to get the r, maybe I will put the small step beside. Okay, maybe I continue from here. Okay, now I want to get the r. So to get the r, you know that it is a square plus b square square root, right? So my a is a 2, b is a square root 3. So I'm having square root, then a square plus b square. Try to simplify, you have square root 7. And I will keep it as a square root 7 because here they already tell us that in the question, they told us that we want to have the exact value of r. So I will keep it as the exact value, which is the square root 7. Then how about the alpha? So to get the alpha, it should be tangent inverse b over a. So my b is square root 3, a is 2. So by using the help of calculator, we can try to get the answer from calculator. Correct to 2 decimal places, right? So by right, you should have 40.89 degree. Okay, so again, correct to 2 decimal places, they did mention it in the question. Okay, so after I get the value for r, after I get the value of the alpha, then you can continue to rephrase it become square root 7 cos x minus 40.89 degree. Okay, so this is how we expand the original expression, and finally we try to apply this general formula and get it into the r cos x minus alpha pattern, right? Okay, so this is what we have for part number 1 for question number 6. Okay, so let's continue to part number 2. Okay, so for part B, what did they ask us for part B? And now they want us to find the value of x that is between 0 and 360 when this whole expression is what we show in first part just now, right? And we successfully get square root 7, then cos x minus 40.89 degree. Okay, takes its least possible value. If this whole expression is minimum, okay, so by using the original expression, right, because we have cos something plus another cos x, it is quite hard for us to predict when will I have the least possible value. Therefore, I have to refer to the answer, since this expression can be is equal to this expression as well, right? So this expression from here, because it has a single cos in the expression, therefore it's easier for us to see where can I get a minimum value for this expression. So to get the least possible value, right, it means that the cos whole thing here must be equals to -1. Okay, right? When the cos is equals to -1, then the whole expression here will have a minimum value. And if cos equals to +1, which is the maximum value for the cos, then this whole expression will have the maximum value. Right, so now we are interested for least possible value, right? Therefore, you can straight away write out that when cos x minus 40.89 equals to -1. And you want to try to solve for this equation. So what's the value for x minus 40.89? Okay, so you have to press the calculator. You can use calculator to help you, cos inverse -1. So by right, you should able to get cos, right? So it should be 180 degree. Okay, so we are only interested for the x which is between 0 and 360 lah. Therefore, I will try to bring 40.89 over. Okay, then by right you have the answer 220.9 degree. And you can see that this answer is in the range required, which is from 0 until 360. Okay, so my final answer is 220.9. Right? But of course, when you want to start, you refer to this one, least possible value is happen. Okay, we can get the least possible value when the cos value is equals to -1. Okay, right, so this is how we solve question numbers. Right, so we are now at question number 7. We are given an equation of a curve like this, and then they want us to show that the dy dx can be written here, something like this, as a fraction. Okay, so if you have a look for this equation, right, basically you know that the y cannot be separated clearly from the x. Okay, because you have ln, the y inside the ln, and also you're having the y on the right. So I don't think that you're able to separate the y at one side, purely at one side, and then x on the other side, or you cannot express y in terms of x. Okay, so for this kind of question, you need to apply implicit differentiation. Okay, so we need to differentiate term by term. Excuse me. So let's have a look for this one. I want to differentiate ln. So to differentiate the ln, right, you are bringing the bracket down. Okay, become the denominator, which is 1 over x plus y. After that, you need to multiply the differentiation of this whole bracket. Differentiate the x, you get a 1. So it is with respect to x, so dx are related to x, so dx, usually we didn't write out. Then you put a plus, differentiate the y, you get a 1. But because this is something related to y, so I'm having dy over dx. I need to multiply a dy dx at the back. That equals to, differentiate the x here, you get a 1, minus 2 is a constant, you just copy, and then when you differentiate the y, you also get a 1. Again, because this is a differentiation related to y, I have to put the dy dx at the back. Okay, right, and after that, I try to rephrase this equation by grouping all the dy dx at one side. So first of all, I want to get rid of this one first, 1 over x plus y. So to get rid of 1 over x plus y, what am I going to do now is I want to bring it over. I want to bring it over, become on the right hand side. So to multiply them, so 1 multiply with x plus y, I have x plus y. Then 2 multiply with x plus y, I write it like this, and then I'm having dy dx. Okay, so next step, I want to group all the dy dx together. So I will bring this particular term to the left-hand side. So if I bring it to the left-hand side, what am I having here is, I will have 2, then x plus y dy dx plus dy dx, then equals to x plus y minus 1. Okay, so this particular term on the left-hand side, bring it over, become minus 1. Okay, factorize out the dy dx. And then from here, you can see that I'm having 2x plus y, then plus 1, equals to x plus y minus 1 on the right. And now, I think the answer is quite obvious, right? If I bring the bracket, okay, to the right-hand side, it will become divide. And from here, you can see that this is how we get the answer that they want us to show. Okay, all right, so this is how we solve question number 7, part A. And let's continue to part B. Okay, so for part B, they are saying that find the coordinate of the point, that means x and y lah, okay, on the curve where the tangent is parallel to the x-axis. Okay, when we are talking about tangent, right, basically it is the line. So they say the line, the equation of tangent, the tangent line is parallel to the x-axis, which means that the gradient of the tangent, okay, you're having the line like this. So maybe I draw the line for you first. So your tangent is parallel to the x-axis. This is the tangent. So when you're the tangent parallel to the x-axis, that means the gradient of tangent, which is dy dx, should be equals to 0. Okay, so this is actually a keyword that you should know how to link it with the formula that we have. Okay, so first we will start with dy over dx equals to 0 first. What is my dy dx just now? So my dy dx just now from part A is x plus y minus 1 divided by 2, then x plus y plus 1, right, equals to 0. If I want to have dy dx equals to 0, then what I have here is x plus y minus 1 equals to 0. And then to get the coordinate for y and x, I need to solve this equation with the original curve equation that I have. So I rephrase it first, become equation number 1. And from the part A, right, just now we have our original line equation. So what is my original line equation? This is the original line equation that I have. X plus y equals to x minus 2y. And I assume that this is the second equation here. So to get the coordinate of x, y, I need to solve these two equations simultaneously. Okay, to get a coordinate. Right, so I will start equation number 1 into equation number 2. So from here, let's see what can we get. So I'm having x, then y will be replaced by 1 minus x. Okay, that equals to 2 minus 2. Again, y is 1 minus x. Okay, so on the left, I'm having ln 1. And then on the right, I'm having something like this. Okay, so again, what's the value for ln 1? You should know that it is equals to 0. So if I rephrase it, I'm having 3x equals to 2. And I get x equals to 2 over 3. So when you get x equals to 2 over 3, substitute it back into the equation number 1. And you can see that y is equals to 1 over 3. Therefore, the coordinate that gives us the tangent with gradient 0 is at this particular point, where x equals to 2 over 3 and also y equals to 1 over 3. Okay, yeah, so this is how we solve question number 7. Okay, so question number 8. All right, so we are given a diagram and then they are telling us something about the diagram in the question. So OABCD is a pyramid with the vertex D, and then the horizontal base is a square. Okay, and then the square is with the side of 4 units. Okay, then the HOD is vertical and OD is 4. So you should know that this is 4. All the sides here are also the 4. Okay, at the bottom, at the base. Okay, alright, then the unit vector IJK are parallel to OA, OC, and OD respectively. You can see that they actually label out the direction for IJ and K. So midpoint of AB is M, and the midpoint of N, and the point N on CD is such that DN equals to 3NC. So find a vector equation for the line through M and N. Okay, so here they want to find a vector equation, and they want to find a vector equation for the particular line MN. Okay, so to form the vector equation, right, I need the direction of the line MN. So I need the direction of MN first. I need the vector MN first. So before I can get the MN, I need to find out the position vector for the M and also the position vector for N, right? So to let you see clearer, I will write my solution here at this part. Okay, so to go for the M, right, start from the position, all the position vectors should start from origin O. Okay, so I will want to go to the M. So to go to the M, I want to get OM lah. So to get the position vector for M is actually OM. So that means start from O, go to the M. So the very first point I want to stop is at point A. So I'm having OA. From O to A is 4 units, right? So it should be 4i in the I direction. After that, from A, I want to go to M, and I will stop at M here. This is how I form the position vector for the M. So from A to M, you know that M is the midpoint, therefore it should be 2 units. And what's this direction? So this is a direction that is parallel to the direction of J. So I'm having plus 2J. So I already get my vector equation of OM. Okay, so you can write it as 420 in the column vector form, or you can write it as 4i plus 2j. Okay, so this is the answer for OM. Not the final answer yet, okay, because our final answer should be the vector equation for the line OM, right? Okay, then now I will need to find out the position vector of N. To find the position vector of N, I might need something to help me to start with, because to go to the N, right, from O, you will see that I need to go through the slope. Okay, no matter how, I need to go through the slope where it is quite impossible for us to express the slope in IJ and K. So what we need to do is, you can always refer to the extra information provided here. They are telling you that DN equals to 3NC. So I will use this particular information provided to find out the ON. Okay? Alright, so let's start. I will become the vector. So dn equals to 3nc. What's the meaning of dn? Dn should be do plus on. Okay, equals to 3, then no plus oc. Then this is how you get the nc lah. Okay? Right, so do means negative OD. I prefer to rephrase everything in the position vector form. Then negative on plus oc. Okay, so if you try to rephrase everything slowly, you have 4 on equals to 3 oc, then plus od. Okay, so what is 3 oc plus od? So you can have a look here. OC means from O to the C. It is in J direction and 4 unit, right? So you're having 4J plus, then OD. So what is the OD? OD is in the K direction. Okay, and then it is also 4 unit. Therefore, you're having 4K. And this is actually 4ON. So finally, if I want to get the ON, then it should be divide the whole thing on the right hand side by 4. So when you simplify, you're having 3j plus k. Okay, so this is your position vector of n, or you can write into the column vector form where there's no direction for I, right? So 0, 3, and 1. Okay, so of course, this is not the end for the question yet. I need to find the vector equation for the line. Okay, so to find the vector equation, I need two things. The general formula is R equals to A plus dP. Okay, A is the passing point. A is the passing point for the line, so you can use either OM or ON for our case here. So no problem, I have both ready, right? Okay, so what's the direction? P is the direction of the line. So to get the direction of the line, you can find either MN or you can find out MN or NM. Either one also can. Okay, alright, so since I already have the passing point, no problem at all. So now I want to take some time to find out MN first. So MN means MO plus ON. Okay, then by using the column vector, so MO become -4, -2, and 0. Then plus. This one is a 0, yeah? Okay, then plus ON, 0, 3, 1. Okay, so if you try to simplify them, the direction that you get is -4, then 1, and also 1. Okay, then now I already have most of the information that I need to form the vector equation. Okay, so what am I going to do now is just write out the answer for vector equation. So I'll write it out here. Okay, so vector equation. Like what I show you here, it is what? It is A plus TP, right? Okay, so to get the vector equation, what's the passing point? If I'm having MN, then it will be good if you use OM as the passing point. So I'm having 4, 2, 0, then plus T, and then -4, 1, and 1. So this is one of the answer. Okay, then the other option is you can also show them by using the passing point ON and the direction NM. This is MN, right? Okay, this is MN. So if I have NM, it will be 4, -1, and -1. 4, -1, -1. So another answer for the equation is, you can use ON as a passing point, which is 0, 3, 1, plus TP. So P will be 4, -1, and -1. This is all. That means you need to show them only one of the answers. Okay, all right. So both answers here will be accepted, but you need to just show one in your solution. Okay, all right. So this is how we form the vector equation for the line MN. Okay, so let's proceed further to part number B. Okay, so for part number B, they are saying that, okay, I want you to show, they want us to show the length of the perpendicular from O to MN is 1 over 3 multiplied with square root 82. Okay, so for me, right, basically I will not bother what is the original shape here. I just know that MN is a line. MN is a line, and then they want you to calculate the length from O, perpendicular distance from O to MN. So this is the O. Okay, and then this highlighted line is the length that they want you to find out. Okay, alright, so to make the calculation easier, I will label the foot of perpendicular from the O to the line MN as F. So which means that I actually want to find out the length or the modulus of the vector OF, correct or not? So this is the shortest distance or the perpendicular distance that I have from O to MN. Okay, so my aim is to find out the OF modulus. Okay, alright, so what is the step that I should go through to build up and find out the answer here? So first of all, I want to find the position vector of OF first. The position vector of F. Okay, since the F lies on the line MN, right? Therefore, the position vector of F is equals to the vector equation that we formed just now. Okay, alright, so you can see that since F lies on the line lies on the line MN, therefore the position vector of F is equals to the vector equation of line MN. So for me, I'll write it like this. So I'm having 4, 2, 0, then plus, maybe I use S. Just now it is a T, right? So that means when T equals to a certain value, you'll get the OF. Okay, so I replace it by using S. Okay, then I'm having -4, 1, and 1. Okay, if I combine everything together here, I will have 4 minus 4s, 2 plus s, and then s. So this is my OF, the position vector of F. Okay, so that's the first step. Second step, we know that the vector OF and the line MN are perpendicular to each other, right? Therefore, you can actually use a result for perpendicular vectors one, where OM dot with MN should be equals to 0 because they are perpendicular to each other. Okay, so what is OM here? You're having 4 minus 4s, 2 plus s, and also the s. Dot product with mn. So your mn is negative 4, 1, and also 1, and you let it equals to 0. So I'm having negative 16 plus 16x, 16s, then plus 2 plus s, then plus s. Okay, that equals to 0. If you didn't do any careless mistake, right, by right, you should get the value of s, which is equals to 7 over 9. Okay, so this is the second step. First step, you try to find out the position vector of f. Second step, you know that OF and also MN are perpendicular to each other, so you use the result OF dot product with MN equals to 0. Then you get a value for s. So what is the main purpose for us to find the s? I want to substitute s into the OF vector. You can see that there's a s. There are some s here in the position vector of f, right? So I want to substitute s inside the OF to get the vector. So now, sub s equals to 7 over 9 into OF. Okay, so what do I get? So I will have OF equals to, you try to use calculator to help you a little bit now, alright? So by right, you should get 8 over 9, then 25 over 9, and also 7 over 9. Okay, so I successfully get the vector OF already, so it should be no problem for us to find out the magnitude or the modulus of OF. Okay, so now continue further. I want to find out the modulus of OF. Okay, so it is square root 8 over 9 square, 25 over 9 square, and also 7 over 9 square. A square plus b square plus c square square root, right? Okay, so again, you can try to use the calculator to help you to sum up all the terms inside first. So you should have 82 over 9. So I think the answer is quite obvious already. Square root 9, okay, can be written as 1 over 3. Square root 82, they want us to keep it as square root 82. So this is how we get the answer, where the perpendicular distance from O to MN should be equals to square root 32 over 3. Alright, so this is how we answer question number 8. Okay, so now we are at question number 9. Right, so we are given the function fx. This is what we have, and then they want us to find the coordinate of the stationary point. So highlight the keyword stationary point. Okay, so basically when you see stationary point, it means either maximum or minimum. So to find the x coordinate of the stationary point, you need to apply differentiation. Right, so to apply differentiation, since this is actually a fraction, you can see it is a fraction. So for me, I would like to apply the differentiation by using the quotient rule. So the formula can be get from here. You can get it from here. This is the quotient rule. Okay, some students, they might want to change it, become the product rule also can, where you bring the both bracket up, become a bracket power negative, multiply with another bracket power negative also can. You can use the product rule if you want. Right, so for me, I will just follow the pattern where it is a fraction. So I will use the quotient rule for the differentiation. Okay, right, so let's start. The formula for the quotient rule is uv equals to v square. Then I'm having, you copy the bottom, differentiate the top, become du over dx, minus, then differentiate the bottom, copy the top. Okay, right. So this is general formula lah. Okay, so let's start. Before we can start differentiate the fraction, I will want to make it become something like this first. I'm having 9 minus x, okay, multiply with x power half. Yeah, and after that, before I differentiate, I will want to multiply the x power half inside the bracket. So I'm having 9x power half minus x power 3 over 2. Okay, then I will start the differentiation. So when I want to start the differentiation, I need to take v squared. So the v is my denominator, right? And I want to square it. So I use the original pattern of the v. I square them. I'm having 9 minus x square. Then the square root x squared, you have a x. So it looks something like this. Then for the numerator, I'm having copy the bottom, differentiate the top. If you copy the bottom, you're having this, the original one. Then differentiate the top. Top is a 1, right? So differentiate 1, you get a 0. Then minus. After that, you need to copy the top, differentiate the bottom. So you copy the top, which is a 1, differentiate the bottom. So when I want to differentiate the bottom, right, I want to use this pattern where I already expand the bracket one. Okay, so differentiate 9x power half, what do I get? I will have 9. Then half I put it in front, copy the x power minus 1 become negative half. Then minus, for this term, power put in front become 3 over 2, copy the x power minus 1 become 1 over 2. Okay. And after that, let's simplify the whole term here. Okay, so to simplify, I'm having 9 minus x square x. Okay, so the term in front is a 0 because 0 multiplied with anything, you'll get a 0. Okay, then how about the term in the back? So to simplify the term in the back, I'm having 9 over 2 square root x. Okay, with a negative, is it? Oh, so the negative, if you want to multiply inside also can. So you have negative 9 over 2 square root x. Negative multiply inside here, you will have positive 3 over 2, then square root x. Okay, then when I want to find the stationary point, right, I need to let the differentiation, the f prime x equals to 0. Okay, so the denominator, you move it to the other side, it also becomes 0. So from here, you actually get the equation like this. So 9 over 2 square root x equals to 3 square root x over 2. Alright, so I try to bring all the x together. So the square root x, I bring it up. I'm having a x here. 2, I bring up. 3, I bring down. So I'm having a 3. Therefore, the x coordinate for the maximum point or the, for the stationary point of this question will be x equals to 3. So they are only interested in the x coordinate. So we can stop here. No need to find out the coordinate of y in further. Alright, so this is how we solve part A for this question. So let's proceed to part number B. Okay, so 9b, by using the substitution u equals to square root x, I need to prove that the integration of the function just now equals to ln 5 over 3. Okay, so since they already tell us a very clear keyword that it is a substitution. So this is a very clear keyword. You have to use a substitution technique for the integration in this part. Alright, so this is what they tell us. So we will start from substitution given. So they give us the equation where u equals to square root x. So we'll start from here. Right, so I'm having u equals to square root x. So first of all, I want to find out the differentiation first, du dx, so that I can substitute all the important things later right into the equation, into the integration. So x power half, I put the power in front, copy the x power minus 1, become negative half. Okay, then I'm having du equals to 1 over 2 square root x dx. Okay, so this is so far what I can get. And then now, because all the original question here, right, the limit 4 and also the 0, the limit 4 and 0 also belongs to the value of x, I also need to change it become u. So how to change the limit become u? So when x is equals to 4, what happened to the u? Okay, so substitute x equals to 4 into the equation. So u equals to square root 4, you get a 2. And then same thing happened for the lower limit, x equals to 0. What is the value of UA? So you substitute the 0 inside this equation by the substitution. In the substitution, you're having square root 0, which is a 0 as well. Okay, so seems like everything is done. Then you can start to change the fx function, become everything with the u before you start the integration. Alright, so let's start. So I'm having 0, 4. So our fx just now is 1 over 9 minus x with square root x, then dx. So this is my original equation. Right, so you need to slowly replace all the x become something with the u. So what's the limit for? 4 is the value of x ma. So just now you already know that if I want to change it become u, the limit become 2. Then the lower limit, 0, the u is also a 0. Okay, so the numerator on top I just copy, then divided by, I just copy. 9 minus x, I copy the 9. What is the x? So square root x is equals to u. Alright, square root x is equals to u. Therefore, the x can be written as u squared. So I put it as minus u squared. Okay, then I want you to have a look for this one. I have the fraction 1 over square root x dx. How to replace this 1 over square root x dx? You can get it from here actually. Just that for this equation just now, I'm having du equals to 1 over 2 square root x dx, right? So the 2 here, I want to move it to the other side, become 2. So you can see that now 1 over square root x dx, 1 over square root x dx can be replaced by using 2 du. So 2 du. Okay. So eventually my integration will look something like this, 2. And then if you have a look here, this is basically a quadratic factor, right? And you can further factorize it, become 2 linear factor at the denominator. So you're having 3 minus u and also 3 plus u du. Okay, so we already successfully changed all the x become something in u. And now from this step, okay, basically you need to know that what is the next technique that we need to use to get the integration. So very obvious, I think you can see that it is a linear factor here. There are linear factor here. So to integrate this kind of rational function, you should find out the partial fraction first. Alright, so for the partial fraction, I will write beside. Now, I want to separate this into partial fraction. So 2 over 3 minus u and 3 plus u equals to a over 3 minus u, then b over 3 plus u. Okay, so what's the 2 here? Okay, so I want to multiply the whole equation by using the original denominator. So I left the 2 only on the left. A, I'm having 3 plus u with me. And then b, I'm having 3 minus u. So now I need to decide the value of a and b. So I will let u equals to 3 at first. When I let a equals to u equals to 3, then my equation here, 2 is still a 2. Then 3 plus 3 is a 6, so you're having 6a. So your a basically is equals to 1 over 3. Right or not? Okay, then after that, for the b, you need to let u equals to negative 3. Okay, so if I let u equals to negative 3, this part becomes 0. So what am I having now is 2 equals to 3 minus negative 3, I'm having 6b. And the b here is now equals to 1 over 3 as well. Alright, and from here you can see very clearly that my partial fraction here will be 2 over 3 minus u and also 3 plus u can be written as 1 over 3 because both a and b are 1 over 3, right? So if you want to write out, or maybe you can write like this. Okay, you put the 1 over 3, you have 1 over 3. Then 3 minus u and also 1 over 3 with 3 plus u. And now I want to substitute this partial fraction result into my integration part, integration step to continue with the integration. Okay, since I know that this is 1 over 3, you're having a constant 1 over 3, this also having constant 1 over 3, before the integration, usually I will prefer to take out all the constant together. So I factorize out the 1 over 3 in the integration, and then I will have 1 minus 3 over 3 minus u, and also 1 over 3 plus u. Then only I start the integration. Alright, I prefer to take out all the constant first before the integration. Okay, so I copy the 1 over 3, which is a constant. Integrate 1 over 3 minus u, you have ln 3 minus u, then divided by the differentiation of 3 minus u. So you have negative 1. You have to divide it by negative 1. Then plus, integrate this, you have ln, then 3 plus u. Then plus c. Okay, when you try to simplify this again, you're having negative ln 3 minus u plus ln 3 plus u. Oh, sorry, I shouldn't put the plus c at the back, right? Because this is a definite integral, so I have to put in the limit basically. So I have to put 2 and 0 here. Then I have to put 2 and 0 here. Okay, so to before I substitute in the limit, I want to combine these two terms together. I'm having negative ln A plus ln B. So it is something like ln B minus ln A. So when you're having ln B minus ln A, right, you can group them together, become ln B divided by A. Then put in the limit 2 and 0. Okay, put in the 2. So 3 plus 2 is a 5. 3 minus 2 is a 1. So and you're having ln 5. Then minus, when you put in the 0, it will be 3 divided by 3 equals to 1. So ln 5 minus ln 1. And since you should know that the value of ln 1 is 0, so from here, I think the answer is very, very obvious. You successfully get 1 over 3 multiplied with ln 5 for this integration. Okay, alright, so this integration basically it involves maybe two parts. The first part is the integration by using substitution, where you need to change all the x become something with the u first. And then when you have something in the u, you need to apply a second technique where to integrate the rational function, you need to change it become partial fraction first. Then only you can continue further with the integration. Right? Yeah, so this is how we solve question number 9. Okay, so we come to question number 10. There's a large plantation of area 20 kilometer square is becoming infected with a plant disease. So at the time t years, so maybe for this here I want to emphasize the unit of the time, which is in years. Alright, then the area affected is infected is x kilometer square. So the area infected can be denoted as x, and the rate of increase of x is proportional to the ratio of the area infected to the area not yet infected. Okay, so because of the keyword rate, okay, and then they are talking about the rate increase of x, which means that if I want to write out the symbol for rate of increase of x, it should be dx over dt. Okay, they are talking about rate, so the symbol should be something over time. Equals to, it is proportional. So proportional means it is equals to a number multiplied with something else. So proportional, I don't know what's the value. I will put it as a k, constant k, to the ratio. So ratio basically means that the fraction. Alright, so the fraction, something divided by something, which is a ratio. Okay, so the ratio of the area infected. So area infected means x to the area not yet infected. So if let's say area infected is x, then ratio, so I'll put it in a fraction form, then to the area not yet infected. Total, I'm having 20 area. So the area not infected will be 20 minus x. Alright, so if I put it inside my equation here, I will have k multiplied with x divided by 20 minus x. Right, so this is basically how we form the differential equation from the explanation or maybe the description from the question. Alright, so maybe I can write down this one in my step first. So I'm having dx over dt equals to k and then x divided by 20 minus x. This is basically what I directly get it from the question itself. Right, so they give us extra information here. When t equals to 0, x equals to 1, and also dx dt equals to 1. So by providing this information, right, they want us to show that the x and t satisfy the differential equation of this. So you can see, compare what they show us here and also what we have with us. We need to actually find out the value of k, and to show that k is equals to 19. So how to show them? Just substitute the necessary value from here, which is provided in the question. Right, so I'm having dx dt equals to 1. and then I'm using x equals to 1. Right, so you can write something like this. When x equals to 1, dx dt equals to 1 as well. This information, or you substitute this one into your equation just now, then you will get 1. Dx dt equals to 1, right? Then substitute 1 into the x, you will have k divided by 19. So I think it is quite clear to see that k equals to 19. Right. Then rewrite the equation again. This is how you actually get dx dt equals to 19x divided by 20 minus x. Right, so this is the very first part of the question number 10. Alright, then now let's proceed further to part number 2. For part number 2, they want us to solve the differential equation. After you solve, you have to show when t equals to 1, the value of x satisfy this equation. Okay, so of course we need to try the first part first. Okay, so solve the differential equation. Alright, so I will copy down our differential equation from part number A just now. I'm having dx dt equals to 19x divided by 20 minus x. Okay, so first step, we try to separate all the same variable to one side. That means I want to keep all the x on this side, all the t on the other side. Okay, so if I want to bring the x and also 20 minus x to the other side, I'm having 20 minus x become the numerator divided by x as the denominator with the dx. I will keep the 19 on the right hand side with the dt. Okay, so some students might ask, can they actually change the 19 to the left hand side? Actually can also. Then you're having 1 here. So at this part you have 19, something divided by 19x. For me personally, I prefer to keep all the constant on the right. So I will just keep the 19 on the right hand side. Okay, then now I need to slowly start the integration process for this question. Right, so 20 minus x divided by x, I cannot integrate it. I will want to separate it, become two different terms first, where I'm having 20 over x minus 1. Okay, if I change my equation something like this, then only I can start the integration. So integrate 20 over x, I'm having 20 ln x. Integrate the 1, I'm having the x. Equals to integrate 19 towards dt, I'm having 19t plus c. Okay, then now, of course, I need to further figure out what is the value for c here. And how can I figure it out? We can try to use back the information given on top. So they did tell us that when t equals to 0, x equals to 1. So I'm going to use this result in finding out the c. So given t equals to 0, and then x equals to 1. Substitute the value inside the equation that you solve. So you're having x equals to ln equals to 1, right? So you're having 20 ln 1 minus 1 equals to 19 times 0 plus c. So you're having c equals to negative 1. Okay, so then of course you need to rewrite your equation again. So I'm having 20 ln x minus x equals to 19t minus 1. So basically this is the answer after we solve the differential equation. So we actually settled the very first part in this part number B question. Solve the differential equation, done. Alright, then now they want us to show that when t equals to 1, then the value of x satisfies this equation. So we are trying the second part now. So given or when t equals to 1, they want to know what is the x, and they want you to show that x can be written into this formula. Right, so when t equals to 1, substitute into our solution here, the particular solution here, I'm having 20 ln x minus x equals to 19 times 1, then minus 1. Okay, 19 minus 1, of course I'm having 18. So we might need to think a way, okay, to change everything very carefully. Okay, because I can see that there's a 0.05x on the right hand side as the power of the e. So to me, I think to get the e, I need to bring the ln over. But before I bring the ln over, I have to ensure that this x is on the other side. Therefore, I'm having 18 plus x. Okay, then there's no 20. Okay, before I want to make the ln disappear, bring it become the e power something, I need to make sure that all the power of all the number are being moved to the right hand side. So now the 20, I want to bring it to the other side, become divide. So 18 divided by 20, you get 0.9. Then 1 plus 1 divided by 20, you get 0.05x. So I think the answer is quite obvious, right? Therefore, now last step, I want to bring the ln over. When I want to bring the ln over, the base is e, right? So you're having e, then 0.9 plus 0.05x. Again, so we successfully show what they want us to show. So this is what you have for part number B. Okay, then let's continue to part C. So for part C, now they are saying that use an iterative formula based on the equation in part B with an initial value of 2. So here they give you initial value of 2. Okay, to determine x correct to 2 decimal places, give the result each iteration to 4 decimal places. So again, what is our iterative formula? It is provided in part B, which is something that we showed just now. Okay, right. So this is what we have, and then now what I want to do is I want to find out the value of x by using this as iterative formula. And the initial value given is a 2. Okay, then to get the x2, you just need to substitute the 2 inside the iterative formula. Okay, but of course I'm not going to do this slowly one by one. I will use calculator to help me. So you can have a look for the calculator, and first you can type in the formula. So the iterative formula on the right hand side is e power 0.9 plus 0.05x. So I'm going to key in the formula here. What is the e? E is shift ln, right? And then I want to type in 0.9 plus 0.05x. X is alpha with the close bracket sign. Okay, so once you key in the formula already, then you have to substitute in the first value, right? The initial value. Press calculate. Then you key in the value, which is equals to 2. The initial value given is a 2. Then you press the equals sign. So from here, you have this long value here. All this long value here, we call it as iteration. So we have to write our iteration into 4 decimal places. Okay, so according to what we have from the calculator, your iteration will be 2.7183. Okay, 2.7183, yeah. So in my answer here, I will put in 2.7183. Then how about the next value? Okay, so to the next value, you have to repeat the same process in the calculator. Press calculate, then key in the second value, 2.7183. So 2.7183. Then press the equal sign. And the calculator again give you a long series of values. So we want to put this iteration as 4 decimal places. So I'm having 2.8177. So you just write 2.8177. Okay, so again, next step, I want to find out x power 4. The value for x4. Again, calculate. Press calculate on the calculator. Key in the previous value, 2.8177. Press the equal sign. So you're having 2.8317. So 2.8317. Okay, then if let's say you don't know when to stop, right? Basically, you can check your result on 2 decimal places if there's any repeated value or not at 2 decimal places. As an example, if you have a check for 2 decimal places, right, what you get is 2.72. And then the next one will be 2.82. So I think very obvious, these two values are not the same. Therefore, you continue with the 4th value of iteration. So for the 4th value of iteration, if you check the answer for 2 decimal places, you get 2.83. So 2.82 and 2.83 are still not the same value, right? Not the repeated value, which means you have to continue until you get 2 decimal places value which is repeated. Alright, so of course we have to continue for the 5th iteration, right? So press calculate, then key in the value 2.31, 8317. Then press equal sign and you get 2.8337. Okay, so if you double check the answer with 2 decimal places, you have 2.83 already. If you want to stop here, you can stop because you already have two repeated value for 2 decimal places. Usually for me, I want it to be more secure. Then usually I will go through one more extra iteration. So I go through one more, press calculate, then press 2.8337, then press equal sign, and I get 2.8339. Should be 2.8340. So 2.8340. Again, if I double check the answer with 2 decimal places, I'm having 2.83 again. So now I will confirm that, I will stop here. I will not continue the iteration anymore. And I will I will say that my root correct to 2 decimal places will be 2.83. So you should write like this. Root will be equals to 2.83 as the final answer. Okay, so for all the iteration here, right? For me, I won't write out all these things. This is for checking purpose, right? The green color part is for checking purpose. So when I want to write out all the iteration, all these are 4 decimal places. And then my final answer is correct to 2 decimal places. So all the requirement here basically will be provided in the question. Alright, so you have to read the question very carefully. Okay? Alright, then next one, part D. We still have a small part to go, right? Okay, so for part D, they ask you to calculate the value of T when the entire plantation has become infected. So entire plantation become infected means that the value of infected become 20, right? Because the whole plantation is 20 kilometers square, right? So when the area infected is equals to 20, means the entire plantation infected. What's the value of T? Okay, so again, we recall back the solution, the particular solution that we get in part B. It should be 20 log x minus x equals to 19t minus 1. So I need to substitute the value 20 inside the x, right? So I'm having 20 log 20 minus 20 equals to 19t minus 1. So what you need to do is you bring the 1 over, then try to press calculator to solve for the t. Okay, so correct to 3 significant figure, your t should be 2.15. Okay, so but please take note, for this kind of question, right, the unit basically is very important. When we talk about t, which is related to time, right, the time. So 2.15, what does it mean? Does it mean like seconds, in minutes, in days, in weeks, or is it in months? Or what is the unit? Alright, so according to the very beginning of the question, they already mentioned that t is years. The unit of t is years. So when you want to write the answer in this case, please always remind yourself to put in the unit correctly. Alright, so we are having t equals to 2.15 years. Alright, yeah, so this is how we solve question number 10. Alright, so we are now at the very last question for this paper, question 11. We are given a complex number u, which is negative square root 3 plus I. Then they want us to express u in this formula r multiplied with e power I theta, where I is greater than 0, theta is from negative to positive pi, then giving the exact values for r and theta. Okay, so for your information, right, r is the modulus of the complex number, and then theta will be the argument of the complex number. Okay, when I'm having a complex number u, right, so to find the r, what's the formula? It will be square root a square plus b square, or x square plus y square. So it is actually negative square root 3 square plus 1 square. Not include the I, yeah? Okay, so you're having square root 3 plus 1, which is a 4. Your r is equals to 2. Then how about for theta? Theta will be the argument. Okay, so you try to consider this complex number, right? Which quadrant is it belong to? So it belongs to the second quadrant. So negative square root 3 and 1, let's say. So you're having negative square root 3 here, then this is a 1. So this is the theta that you want to find. Okay, so to find this theta, basically you need to use maybe all the concept of trigger whatsoever, up to you. Right, I want to find out the value of theta. Sorry, the theta should be this one. The argument should be starting from the positive x-axis. This is the argument. the data, right? So the data always, which is, the data should be the argument of the complex number, which must be always measured from the positive x-axis. Okay, so the angle here that I show should be a theta. Right, so to find this data, there are many different ways that you can decide it. Alright, so for me, I'm using a trigo concept. So to find out the answer for the second quadrant, it is actually pi minus the basic angle. The basic angle is the acute angle inside the triangle. So what is this acute angle here? The question mark, what is the question? What is the acute angle in this triangle? So it is actually tangent inverse. Then the height is 1, right? Over square root 3. When you want to find the acute angle, you always ignore all the positive and negative sign when calculating the value here. Okay, then again, by pressing calculator, tangent inverse 1 over square root 3, by right you should have 30 degrees, which is pi over 6. So you take pi minus pi over 6, and you have 5 pi over 6. Okay, so this is how you get the modulus and also the argument for a complex number. Therefore, it can be written in the exponential form, where u can be written as r, which is a 2, then e power 5 pi over 6i. So this is basically the exponential pattern that they want us to show, where your r is equals to 2, and then the data is 5 pi over 6. Okay, so this is what we have for part number A. Then let's proceed to part number B. Now, they want you to show that u power 6 is real and state its value. Okay, u power 6. If you want to use this complex number and then you power 6, the standard complex number, and you power 6, it will involve a lot of expansion. Of course, you want to expand it, no problem, but it might take a little bit time for you to complete the whole process. Alright, with power 6. So you can imagine, if I want to take this bracket power 6, you can get the answer, just that the process might be slightly longer. Right? So what is the purpose? They ask us to find out the exponential form for the complex number. So it's time for us to apply it here. So when you want to find out u power 6, right? Okay, instead of expanding what we have in the basic complex number, we can actually apply it by using the exponential form. So this is my exponential form, which is a u, right? So if I want to find u power 6, that means I will take this whole thing power 6. So this whole thing Okay, so according to the indices rule, the 6 here you have to put it into the power the 2, the number 2. The 6 also you have to multiply with the power of the e. Okay, therefore 2 power 6, what do you get? You have a 64 for 2 power 6. And then e, when you take this power 5 pi over 6i multiply with 6, you left only 5 pi I. Okay, so after you power 6 the u, then what can you do? They want you to show that u power 6 is real and also states its value. So real means that your u power 6 has 0i. You have to show that it has 0i, and then they want us to find out what is the real value that it has. Okay, so how can I find out the how should I prove that it is real, and also how do I find out the real value? Okay, so again we have to recall back the other form, yeah. So there's another form of the complex number where it is modulus argument form. U is equals to r cos theta plus I sin theta. Wait, I think there's a bracket here. R, then r cos theta plus I sin theta. Okay, alright, so this is a modulus argument formula. So you might need to remember it also, okay? So now, what is my r? I know that my r is 64 in this case. And then what is my cos theta? The theta is the argument, it is 5 pi. After we put the power 6 with the u, then plus I sin theta. So I'm having I sin 5 pi. Okay, so by using a little bit help from calculator, you will see that the cos 5 pi is -1. and then the sine 5 pi is 0, so you're having 0i. Which means if you multiply the negative 64 inside, you have negative 64 plus 0i. So you see the 0i, you already know that this is a real number lah, because complex number must have something with the I at the back. Either 2 plus I, 3 minus I, and so on. Right, so since you're having 0i, it's already proved that u power 6 is real. Okay, so you can put a small conclusion beside here. U power 6 is real. And then what's the value for the u power 6? So the u power 6 basically equals to 64. Negative 64, sorry. Alright, yeah, so this is how we solve this part number B. Okay, so let's continue with part C. Okay, so for part C, on the sketch of the Argand diagram, they want us to shade the region whose point represent the complex number z, satisfying the inequality of this, and also the real z smaller equals to 2. Okay, we start with the argument first. So argument z minus complex number u, right? That means argument z minus negative square root 3 plus I. And it should be smaller than pi over 4 and also greater than 0. Okay, so to sketch this complex number, this locus, alright, the locus z, what I need to do is like, I need to first plot the complex number, the u first. So of course, if you want your graph look nicer, right, what you need to do is that you have to roughly measure the correct ratio. When you want to draw, you have to draw the ratio. You try to measure, or maybe try to use a ruler to at least let your ratio looks more, more accurate. Okay, then let's see what should I have here. Maybe I want to have slightly middle, in the middle of my y-axis. Okay, so this is my real axis and this is my imaginary axis. So there, my point, right, the complex number is negative square root 3 for the x and also 1 for the y. Okay, so for me, I will use a ruler to measure. Maybe the negative square root 3 is roughly here. Okay, and then the 1 might be slightly here, maybe somewhere here. So this is my u. So I'll label it as u. Okay, I will draw a line horizontally because I want to know how to shape the area for argument between 0 until pi over 4. So if I draw a horizontal line like this, this is the argument 0. Argument equals to 0 means you measure from the right hand side, the horizontal line from the right hand side, right? There's no angle, the angle is equals to 0. Therefore, the line itself, this line itself, basically is the argument equals to 0 line. This one, the dotted line that I draw here. Okay, by right, you should draw a solid line because there's an equal sign here. Okay, then after that, for the angle pi over 4, you need to measure from the right hand side of this complex number, measure 45 degrees. Okay, so if you cannot measure 45 degrees, what you can do now is you can try to use the ruler also. Okay, measure square root 3 unit on top of 1 on the y-axis. Okay, so you have x-intercept. Sorry, this is a y-intercept, not x-intercept. So you're having a y-intercept where this point itself should be 1 plus square root 3. This point itself. Of course, if you didn't label it, it's okay lah. But I just want to let you know that this is 1 plus square root 3. Okay, and this angle is pi over 4. So please take note that for pi over 4, right, it is 45 degrees. Which also means that how many units you shift in x-axis, you shift the same unit also, or same ratio also at the y-axis. So that's why I said just now from here to here, for the x-axis is square root 3 unit, right? Therefore, for the y-axis also, I need to measure square root 3, which is 1 plus square root 3, is the y-intercept. Okay, and then the shaded region should be somewhere inside here, between the 0 and also the 45 degree. Okay, alright, but now they also want to consider the inequality where the real part of z smaller than 2. So let's have a look. What's the meaning of real part of z smaller equals to 2? real part of a complex number means x. So you want to sketch the area x smaller equals to 2. Okay, then again, on your diagram, you might need to measure where is your 2 first. So maybe your 2 is here, 2 unit. Then you draw a straight line going up. Okay, and they say smaller than 2, right? So if let's say x smaller than 2, by right, you should shade this whole area on the right, or on the left, sorry, of the line, y equals to 2, or x equals to 2, correct or not? So what is the overlapping part of the blue and also the yellow color? So you can see that very clearly it is inside the triangle. So to shade these two areas, the overlapping of these two areas properly, by right, the final answer should be this part. Okay, where it is inside the triangle. Okay, so this is how we solve this part C, question number 1. And then now for question number 2, they want you to find the greatest value of modulus z. Okay, so again, modulus z means that z, the distance of z from the point of 0, 0, I, which is from the origin. For the points in the shaded region, give your answer correct to 3 significant figures. So what is the longest modulus z starting from the origin? So again, you need to use our graph to figure it out where is your furthest, the longest z, or maybe the z with the longest or the greatest modulus. Start from 0, 0. So you can see that the blue color line here is a 0, 0, which is the origin. And then where should you put your z so that the z basically will have the longest distance from 0, 0. As an example, if you put your z here, you use the triangle, the ruler to measure the distance, and if you put the z here, you use the triangle, you use the ruler to measure. Okay, definitely the further z will have a longer distance, right? Okay, so by trial and error, or maybe by some common sense, you will know that this z will give you the longest modulus or longest distance from the 0. And now for the part 2, they want us to find out the coordinate for this z. Okay, so what is the coordinate for this z? So first of all, to find out the coordinate for this z, the x coordinate is very, very straightforward. So what's the x? So I'll put my answer here, easier for you to refer to the diagram. Okay, so the x coordinate for the z, it is equals to 2 because it is along the line x equals to 2, right? Okay, so the x coordinate is a 2. And how about the y coordinate? So I think maybe the y coordinate is something that you need a little bit of knowledge to find out. So the y coordinate of the z, you might need to refer to the triangle that you highlight. Still remember this triangle? Okay, so what is the angle here? Pi over 4, which is 45 degrees. Okay, so you can see if I have tangent pi over 4, right? Okay, it is equals to y over x, no? Correct or not? So this is the y. Okay, and then this is the x. Okay, but I don't want to make you confused because usually y and x should start from origin 0. It's easier for you to have a look. So for me, instead of using y and x, I better use the other thing, which is b and a. So you need to have b divided by a. Okay, so what is the value for tangent over 4? So tangent over 4 is a 1 actually. What's the value of b? I don't know, and I want to calculate it out. And then what is the value for a? Okay, so the value for a, right, you can have a look, it is from 2 and also square root 3. So the distance for the a, right, it should be 2 plus square root 3. Agree or not? Because you want to calculate the length for the base here. You want to calculate the length for the base here, it should be square root 3 plus 2 from the origin. Okay, right, so from here, I know that my b should be equals to 2 plus square root 3 as well. So the distance is also 2 plus square root 3. That means the x and also the y should have the same value, right? For the triangle in a triangle, because it is talking about the ratio for tangent pi over 4. Okay, if I know that b is 2 plus square root 3, right? So what is the coordinate of the z? So the 2 plus square root 3 is calculated from this particular line. What is the y value of this one is y equals to 1, right? Because also you already have the u, which is negative square root 3 plus 1. Therefore, this y coordinate is a 1. So you have to, from the y equals to 1, you have to move up 2 plus square root 3 unit. So it will be 1 plus the distance move up 2 plus square root 3 unit. Therefore, your y will be equals to 3 plus square root 3. Okay, the coordinate of the y. And for this question, they want us to express it in 3 significant figure, right? So if you change it, sorry, let me have a look. Oh, no. So you have the coordinate of y. Therefore, you know that z is having the coordinate 2 and also 3 plus square root 3. And since they are interested to find out the modulus of z, so how to find the modulus of z? Okay, so you have this coordinate and I want to calculate the modulus of z from the origin. So it should be 2 square plus 3 plus square root 3 square. And for the answer that you get, they actually want you to find it out correct to 3 significant figure. So to make it correct to 3 significant figure, what we need to do is just use calculator to help you. Okay, by right, simplify to 3 significant figure, you should have 5.14 as the answer. Okay, so for this part number 2, right, there's no fixed method for you to find out the answer, basically. So you can try to observe some details from your diagram. All right, and usually you can see that they are always using some property about triangle and circle, okay, or maybe some rules that are related to trigo. All right, you can actually try to observe it from the diagram usually. All right, so the blue color in one, basically we are talking about how to solve and get the answer for the part number C and 2. All right, okay, yeah, so I think we have discussed all the questions in this paper. All right, thank you very much for watching this video and happy